Hello, everyone. Thanks for joining me today for the topic Why Atoms Combine. My name is Miss Killinen, and this focus today is mostly an introduction on compounds and bonding. Here are our goals for today. By the end of this lecture, I'm hoping that you will be able to generally summarize the difference between ionic and covalent bonds, and also being able to explain why atoms combine in terms of stability and valence electrons. Let's get going! All right, so the general idea is, okay, why do atoms combine? How come every atom on the periodic table just doesn't stay by itself? Why would they want to come together? Well, the short answer is to be more stable. They want to fulfill something called the octet rule, octet meaning 8, like octopus or octagon. And what that means is having 8 valence electrons in their electron cloud. And just as a reminder, valence electrons are electrons in the outermost energy level. So for example, oxygen has 8 electrons total, but it has 1, 2, 3, 4, 5, 6, the shaded in ones, 1, 2, 3, 4, 5, 6 valence electrons. And then these empty ones are the 2 that it would like to fill in order to be stable. Nitrogen has 7 electrons total. It has 1, 2, 3, 4, 5 valence electrons, 3 open spots that it would like to fill in order to be stable. So that's the idea of a valence electron and the relationship to octet rule. So if this outside level was full, that would be more stable, and that's sort of what elements are trying to do. So there is a group on the periodic table that all the other elements are trying to be like in terms of their valence electrons. They're not trying to change their identity, they're just trying to copy them in terms of their 8 valence electrons. And that is the noble gases. The very far right column on the periodic table. They are called noble gases because, kind of like nobility doesn't mix with other things, they're saying that these elements are already stable. They don't need to form compounds to be stable. And so because of that, they are considered the noble gases. When we're trying to be stable, we being other elements, it's always our goal to get to that noble gas column. And we'll talk more about that in a little bit. So just to clarify, the reason the noble gases are so important is that they are considered chemically stable. They already have 8 valence electrons. This creates the lowest energy state possible. And kind of like people, atoms want to have the lowest energy. They're considered happy. So that's just sort of a colloquial way of saying it, that they're more stable when they are low energy, and then that makes them happy. So let's talk about how can other atoms get happy. Well, there's basically 3 things they can do to become more stable or to become happy. They can lose electrons or gain electrons, or they can share electrons. So when we look at the periodic table, there's 2 groups on the periodic table that it's really easy for them to especially lose and gain electrons. The alkali metals, the far left side, is one of them. Remember that the noble gas column is the goal. That's where we're always trying to get to. Think of it like a game board, and these are like the safe spots. So if you take a look at where the alkali metals are, and then the other group that it's really easy for them to be stable is the halogens, which is this group right next to the noble gases. They're just to the left of them. And this is on the far left of the periodic table, but really just one away if you go backwards. So the reason that they're considered it's so easy for them to get stable is because they're only either needing to lose 1 electron. So if I go from here backwards, I'll be in this column, or from here forwards, I'll be at that noble gas column. So it's considered easy for them to lose and gain electrons because there's only 1 spot away. And we'll talk more about that going backwards and forwards thing in a little bit. But that's what they can do to be happy. But then the question that you might be thinking is, well, wait a second, why the electron? I mean, it's tiny, it barely has any mass. So let's talk a little side note about that. So why the electron? Think of what the structure of the atom looks like. Why would the electron be so important in terms of getting happy instead of the protons or the neutrons? Well, one thing is that they're on the outside. So they are far away from that nucleus, so they're not all tangled up in that dense center, which would be hard for other atoms to get to. So the electrons are on the outside, and then it's the first thing that another atom comes into contact with. So imagine that you had 2 atoms that looked like this. When one atom moves in, the things that are going to interact first are the 2 electron clouds. So then they're going to be able to attract and connect with electron clouds first. And so because they're not tangled up in that nucleus, they're on the outside, they're flying around, it's easier for another atom to do something with these electrons than with the stuff inside the nucleus. So that's why the electron is so important. Okay, so we know why the electron is important. We know what the atoms are trying to do to be stable, gain, lose, share electrons. We got it. But we might now need to talk about how do they do that? Well, how do they get happy? How do they lose or gain or share electrons? Adding energy is one way that you can make an electron move. Think of just the same as like people. If you are a person and you need to do something, you need energy to do that. So adding energy to an element could make that electron move. The kinds of energy we're talking about, these could be things like heat and light. You could take a chemical and heat it up or shine light on it. Think of solar panels. They take energy, light, from the sun, and they make those electrons move, and then that creates a circuit that can conduct electricity, and then that makes energy. So that's one way we can make electrons move, is by adding energy. But the other thing we can do is we can get the electron close to something that is positive. We know that opposite charges attract. So if I can get the electron close to something positive, like maybe the nucleus of a different atom, that nucleus that is positive because of the protons can attract an electron away. So if you have a very powerful nucleus that can get close to another electron, it can actually pull that electron away, and then that's how losing and gaining happens. So the electron can attract it, or the nucleus can attract an electron away, so it gains an electron, which means another atom has to lose an electron. And then sharing will be caused by attraction also, but usually because the two nuclei that are trying to both take an electron, neither one of them is more powerful enough to actually take the electron, so they have to share instead. So adding energy and attractions between negatives and positives are how we lose, gain, and share electrons. So that's how the atoms are getting happy. Okay, so that was a lot of information. So go ahead and take a few moments, pause, and would you please write a level 2 question on the notes we've taken so far? Remember, level 2 are things like book and brain. So there's something in the notes to give you a hint, but then your brain has to fill in the rest of the information. So a level 2 question, go ahead and pause. All right, welcome back. Okay, so we know a little bit of this introduction of what the atom does to be stable, and that's when this idea of bonds, chemical bonds, comes into play. Compounds form in order to make elements more stable, like the nearest noble gas in terms of valence electrons. They lose, they gain, they share electrons in order to get 8 valence electrons. When that happens, those atoms stay together by electric attractive forces called bonds. It's not an actual physical connection, it's an electrostatic attraction, kind of like think of when your socks stick together after the dryer, or kind of the way magnets come together. There's not a physical connection, but there's an attraction there. That is the idea of chemical bonds that keeps elements together in order to be more stable. So let's first talk about when electrons are lost and gained. That's known as an ion. That vocab word ion just means that an atom has a charge. Here's why this happens. When we lose an electron, that is called a cation. And the way this works is that an electron is negative. So if you get rid of something negative, you're going to be more positive. And this is how you can remember it. Cats have pos. So cation is positive because they got rid of something negative. Negative electrons lost actually gives you a plus, a positive charge. And it's generally the metals on the periodic table that do this. Because of where they're located, it's easier for them to go backwards to be like the noble gases and lose electrons than go forward and gain electrons. So cations have a positive charge because they got rid of a negative electron. The other option then is gaining an electron, and this is called an anion, and because you're gaining electrons and electrons are negative, if you gain something negative, you will be more negative. It's like ants at your party. It's negative. Ants at your picnic. And it's generally the nonmetals that do this. Again, because of where they're located on the periodic table, it's easier for them to go forward to be like the noble gases and gaining electrons. And again, we'll talk more about that backward forwards thing in a little bit. All right, but now that you know what an ion is and it has to do with charges, we are ready for you to introduce, I'm ready to introduce to you one of the best jokes ever. Okay, so anytime you see a Saturn ion, whether you're driving or walking through a parking lot, you can look at it and turn to the people around you and say, wow, now that's an attractive car. Because ions have charges and charges attract. It's funny. See, you got it. Okay, go ahead and pause the video if you need to laugh for a while. But then let's keep going. All right, so losing, gaining electrons creates an ionic bond. So this is our first type of bonding that we want to clarify. It's called an ionic bond because there's ions that have opposite charges and are attracting each other. Negative and positive attract, like static electricity, like magnets. The result then is called an ionic compound, a compound made of ions, and the neutral piece is called a formula unit. And yes, the abbreviation is FU. It's the only time you're allowed to yell that out in class and not get in trouble. So when there's ions, so because atoms have lost and gained electrons, there's opposite charges they attract. That creates a compound made of ions, and the resulting neutral compound is considered a formula unit. For example, calcium and chlorine are both chemically unstable on their own. Because of where calcium is located, it's easier to lose electrons, and chlorine wants to gain electrons. This nucleus is strong enough to actually take an electron away, so this gains, this loses. Negative charge, positive charge, and so they come together to be stable. They attract to form a compound because of opposite charges. Positive because it got rid of something negative, negative because it gained something negative, and because of that they attract to each other. And now they create a stable compound that's neutral, and in this case it would be called a formula unit. The other option then is electrons being shared, and these are called molecules. There's two versions of sharing. One of them is a nonpolar molecule. This happens when the two atoms involved have pretty similar strengths of their nuclei, and so neither atom can actually take an electron. They're both trying to take an electron, but neither one is strong enough, and so then they do equal sharing. They're pretty much the same strength. Think like a tug of war game where there is two teams that are both pulling on that rope, but neither team is really strong enough to pull the rope away from each other, and so they're all hanging onto the same rope, but nobody's winning. That would be a nonpolar molecule. Then a polar molecule is when we're still sharing, but it's unequal sharing. This would be like tug of war, where one team is pretty strong compared to the other team, but it's not strong enough to win. So as they're pulling on that rope, the rope is gradually going to one side, but it's not so strong that it can actually win and pull the team over. That would be unequal sharing of electrons. So this is two atoms where one nucleus is quite a bit stronger. So it pulls the electrons a little bit closer, but not enough to actually take it. So that's a polar molecule. So we think of it as, you could also think of it as kind of like a bully, pulling something away from a weaker person, not enough to actually take it, but to kind of pick on that other element. That's kind of what's happening with a polar molecule. So there's two versions of molecule, both involve sharing of electrons, and it happens because all the atoms involved, no atom is strong enough to actually take an electron, but they all are trying to, and so it's the kindergarten rule. If everyone wants the toy, then the teacher says they have to share, exactly. So in this case, the chemistry world is saying, okay, everybody wants to take an electron, you're going to have to share it. It just turns out that some of the atoms are willing to share, but they're still a little bit of a bully because their nucleus is strong enough to actually pull the electrons closer, just not strong enough to actually take it. So ionic compounds with ions, when electrons are shared, that's referred to as molecules. And then you also end up with partial charges. You don't have full ions because the atoms haven't actually taken an electron. It's just that the pulling side is a little bit more negative than the side that's getting a little bit pulled away from, so that's partial positive. So those are molecules. All right, so when you have that happening, polar molecule or nonpolar molecules, so sharing electrons, you create a covalent bond. So it's a bond that forms because the atoms are sharing. They are called molecules, as we already said, and it happens still because they're attracted to each other. The nucleus of atom 1 is attracted to the electrons of atom 2, and the nucleus of atom 2 is attracted to the electrons of atom 1. And so there's still an attraction, and it can be uneven sharing or equal sharing, but they are referred to as molecules. So here's an example. Chlorine is unstable by itself. But if it finds another chlorine, well, of course, both chlorine nuclei are going to be equally strong. So this chlorine can't pull these electrons away from the other chlorine. This chlorine can't pull these electrons away. Everything is attracted. This chlorine is attracting its own electrons and these electrons. This chlorine is attracting its own electrons and these electrons. But look, because of that sharing, now this chlorine has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. This chlorine has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So between them, they're both stable. And this example is actually a good example of something called diatomics. Chlorine is one of our diatomics that it's an element that can never exist as just one atom on its own. It's either going to be in a compound, like for example, hydrochloric acid, maybe HCl, or there's two of itself. So there are 1, 2, 3, 4, 5, 6, 7 elements that do this. This is something that would be helpful for you to just remember. So maybe a couple tricks. Here's one. Come up with a silly sentence to help you remember these, like this. I bring clay for our new house. Doesn't mean anything, but it reminds me that iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen are my 7 diatomics that if they are not already in a compound, they're going to make their own compound with each other. And that's going to be super useful for when we start writing formulas and chemical equations, knowing that you can never just have an H sitting by itself. It's either a pair of its own or it's in some other compound to make itself stable. But if they are in a compound of their own, it's for sure going to be a nonpolar molecule sharing electrons in order to be more stable. So this little side note, go ahead and jot that down, but that's going to become more and more important the more chemistry that you learn. Okay. Whew, once again, lots of information. We got to pause again. Ready? Would you please pause the video and either write 2 level 1 questions, so these are really basic kinds of just look up in your notes kind of questions, or 1 level 3 question, a prediction, a hypothesis, an evaluation, something that makes your brain really put together some pieces. So go ahead and pause the video and write some Costa questions. All right, welcome back. So that was the big information about our bonding. So I would like you to do another processing assignment. Why don't you do one of those cinquains again? Remember, a cinquain is a 5-line poem, not worrying about rhyming, but more about syllables. So in the first line, there's 2 syllables. In the second line, there's 4. And then it goes 6, 8, back to 2. Here's an example in case you need one. Ready? Let me get my poetry voice going. Here it is. Bonding. 2 types, I, C. Gain, lose, share electrons. Minus, plus, polar, nonpolar. Stable. Thank you. Okay, so you write a cinquain processing all of those notes you've taken so far because it's going to help you remember them a little bit better. All right, go ahead and either pause and do that right now or go ahead and do it later and keep watching because I have a little bit more information I want to talk about related to bonding. Here we go. The last topic I want to cover that talks about bonding is something called an oxidation number. It's a big fancy term that means positive or negative number. Every element has one, and it tells us how many electrons must be lost or gained to be like the noble gases. This is that backwards forwards thing I was talking about because that assigned number tells us a lot about what's going to happen to that element. So here's what we do. How do we figure out an oxidation number? Think of the periodic table like a game board. You count forward and backward until you get to the noble gases. You'll do whatever is closer, keeping in mind that just hydrogen is sort of a weird example, and its oxidation number will be +1. This means that hydrogen would like to lose an electron to be stable. Well, that seems weird because you can't go backwards from hydrogen because hydrogen's the first one. But remember, hydrogen is one of those diatomics, so it's never just by itself. So if it loses 1 electron, it still has an extra one left over from that other hydrogen in that compound. So it's okay. So just know that hydrogen is weird and its oxidation number is +1, meaning it wants to lose 1 electron because you're getting rid of something negative, so you're positive. And then the reason we really love oxidation numbers is it helps us understand bonding because when elements come together, the sum of the oxidation numbers must be 0. This means that the total plus adds up to the same as the total minus. And so oxidation numbers help us understand that. So we'll do some examples of that. But first, speaking of 0, what did 0 say to 8? Huh? Nice belt! Picture it, a 0 compared to an 8. You got it. Okay, let's take just a few moments and let's talk a little bit about this periodic table, counting backwards and forwards, oxidation number kind of thing. All right, so we'll come back to the slideshow here in just a little bit. But what I want to talk about is, all right, so here's our noble gas column. Selenium is a great example of something that's not stable because remember, every atom that's not a noble gas is considered unstable. Selenium's got 2 choices. It can go from 34 to 36 to be the noble gases, or from 34 all the way backward to 18, argon, to be like the noble gases. So when I say whatever is closer, it literally is whichever boxes are less. So I can go 1, 2 forward, or however many that is backwards, 16 or something. And so selenium's like, well, whatever, it's easier to gain 2 electrons than to lose a whole bunch. So I will gain 2 electrons to be stable, which means I'm getting more negative electrons. So the oxidation number is -2. That's the idea about an oxidation number. How about yttrium? It's fun to say. Yttrium has 2 choices to be stable. It can either gain electrons and go from 39 all the way to 54 electrons to be stable, like this noble gas, or from 39 backwards to 36. So again, it's going to do whatever's closer. Chemistry is lazy in the sense of doing whatever's easier. So yttrium goes backwards 1, 2, 3. It's losing negative electrons, so its charge is actually positive. So that's the idea behind oxidation numbers. Lithium, same idea, from 3 forward to 10, or it can go backwards from 3 to 2. Well, it's easier to lose 1 electron. Losing 1 electron means it's getting rid of negative charge, so it's actually a positive 1. That's the idea behind oxidation numbers. So you literally can just count, and then these ones in the middle, eventually I'm going to give you a reference sheet that will give you those instead of having to do the counting thing, because when they're in the middle, it's hard to decide what they're going to do, like whatever's closer. So instead, what we do is we say, okay, all of these atoms pretty much are going to try to go backwards, lose 1, positive 1. These are generally going to try to lose 2 electrons to go backwards 2 spots. These ones are going to gain 2, these are going to gain 1, and then these ones in the middle, you can kind of count or you'll get them on a reference sheet. So that is oxidation numbers, all right, in general, how we use oxidation numbers. Let's try a couple examples of these. All right, so what we're going to do is some egg samples. Here we go. Go ahead and practice these together. So how would these elements combine in order to make their oxidation number equal to 0? So basically we're saying how many each of them do we need. So sodium, if you look at where it is on the periodic table, is a +1. Iodine is a -1. This wants to gain an electron, this wants to lose an electron, so when they come together, it's a perfect match. One Na and one I makes a stable compound. Calcium, if you look at where it is on the periodic table, go ahead and glance at it. It wants to go backwards 2 spots to be like the noble gas. So calcium is a +2 charge, but chlorine can only take 1 electron. Chlorine is a -1. Look at where it is on the periodic table. It only has to go forward 1 spot to be as stable like the noble gases. So if calcium is trying to give away 2, but 1 chlorine can only take 1, we need 2 chlorines to balance that +2 charge on calcium. So CaCl2, 2 chlorines, would make a stable compound. Sodium is a +1. Again, we already said that. It wants to go backwards 1 to be stable. And oxygen actually wants to gain 2 electrons. Look at where oxygen is. It wants to go forward 2 spots to become like the noble gases. So this time we'll need 2 sodiums, a total charge of +2, to balance 1 oxygen, which has a total negative charge of 2. So Na2O1, or 2 sodiums, 1 oxygen, will make a stable compound. Remember, hydrogen has that +1 charge. Bromine, look at where it is a -1 charge, so they would be a perfect match, 1H, 1Br, to make a stable compound. Magnesium, take a look at where it is. It's in the same column as calcium, so it's going to lose 2 electrons to be stable. Chlorine, we already said, is a -1, so once again, Mg and 2 Cl's would make a stable compound. That's the idea. I'll do a few more of examples like that at the end when I review our note sheet. So if that was a little fast, go ahead and keep watching and you can review at the end. So here's our summary. Atoms combine with other atoms because they want to be like their noble gas, nearest noble gas, going backwards and forwards on the periodic table in terms of 8 valence electrons. There are a few exceptions to this: boron, beryllium, lithium, helium, hydrogen. If you take a look at where they are on the periodic table, quick find them. You notice that, where are they? Yeah, they're all at the beginning. This means they're really, really small. So that means that their nucleus is a tiny baby nucleus with barely any positive charge, so it cannot hold on to 8 valence electrons. That's just too much. This would be like if you take a magnet and it's holding up a couple papers on your refrigerator, and then you put more and more and more papers on that refrigerator. Your magnet can't attract through all of those papers and it falls off. That's what this baby nucleus is like. The nucleus is there and it has a positive charge, but since it's so small, it can't hold on to all 8 electrons, so they would just go away anyway. So it turns out that these elements, they're exceptions to the octet rule. They're okay with only having 2 valence electrons. just want you to be aware of that for now. You'll learn more about that the more chemistry you learn. All right, so you listened to a lot of information, so thank you so much for your attention. You now could finish your Costa questions, you could finish your summary, you could try the Synquane, you could look at some book problems if you have a specific textbook to go with this topic. And then just whenever you go back to class, whether it's for Miss Killinan or for another teacher, go ahead and just clarify any questions with them. Thanks so much for listening. Okay, before I lose you though, I am going to spend just a little bit of time on this note sheet. So if you are not in Miss Killinan's class, go ahead and stop the video now because this will just be specific to her class. But I want to review the notes that you should have caught on from watching that video. So this is going to be the fast forward version summary of that lecture you just heard. Here we go. Why do atoms combine? They want to be stable, which means 8 valence electrons, all right? Why the electrons? Well, remember, it's because it's on the outside. The nucleus doesn't hold it as tightly because it's farther away. And it's the closest thing that another atom's nucleus can get to. So that's the first thing that gets attracted from another nucleus. And so that's why the electron. Okay, so what do we do to become stable? How do they do this? Well, there's 3 things that we can do. We can lose electrons or gain electrons, that goes together, or share electrons. How do we make that happen? Well, you can add energy to an atom. Adding energy will make those electrons move more, and that can make them be lost or gained. Or you can do negative and positive attractions. The nucleus, which is positive, can attract a different element's negative electrons to itself. Or if they're both trying to gain electrons, that attraction between the 2 nuclei will make them share electrons. All right, let's focus on losing and gaining here. So losing electrons creates what's known as a cation, and that's because it's getting rid of something negative, so it's positive, and it's generally the metals on the periodic table that do this. Gaining electrons is called an anion, and since you're gaining something negative, the atom has a negative charge, and it's generally the non-metal element. So take a look at your periodic table. The dividing line for metals and non-metals kind of goes right along this stair-step idea. So here's the metals, so look at where they are. So these would be examples of metals. If they go backwards, it's closer to get to the noble gases. But the non-metals, it's easier for them to go forwards, gain electrons to be like the noble gases. So that's what we mean by metal elements are more likely to lose electrons, non-metals more likely to gain electrons. Now, when that happens, that creates a type of binding called ionic bonding. Because you have opposite charges, negative and positives attract, that's called an ionic bond, and the resulting neutral compound is stable and is called a formula unit. Now, the other option is that electrons can be shared. This is known as a molecule, and there's 2 ways that you can share evenly or unevenly. So a polar molecule is an uneven share. That's like 2 teams playing tug of war, where one team's a little bit stronger, just not strong enough to win. And nonpolar sharing is like 2 teams playing tug of war, where both teams are perfectly matched. They're both pulling, but neither one is really taking more electrons than anybody else. When electrons are shared, this is called a covalent bond instead of ionic bonding, and the resulting neutral compound is considered a molecule. And even though they're sharing unevenly, even though they're not actually charges, they can have partial negative and positive charges based on that uneven pull. All right, and then the other little side note we talked about was these things called diatomics: iodine, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen. I bring clay for our new house. A silly little sentence to remember these 7 atoms or elements that can never exist on their own. You'll never have a Cl. It's either Cl2 making each other stable, or it's Cl in a different compound. Here's another way to remember them. Take a look at what they are. So here's this iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and then hydrogen you just have to remember is off by himself. But look at this. It kind of looks like the number 7, knowing that the 7th one is hydrogen, kind of way over here. So just remember that's another trick of how you can remember those 7 diatomics. All right, so that was a lot of processing information, so do that Synquane to help you remember all of these notes. 5 lines, 2, 4, 6, 8, 2 syllables per line. Okay, let's review oxidation numbers one more time. So magnesium is right here. It's closer for it to go backwards 1, 2 to be the noble gas column. Backwards 2 means less electrons, less negative, so the charge is positive 2. Chlorine is a negative 1. Look at where it is. Gaining 1 electron makes it stable like the noble gases. Gaining electron is negative, so a negative 1 charge. But right now, they're not making each other happy. So another chlorine, that total charge is negative 2 balances out the positive 2, and so that's what we mean by the oxidation numbers sum to 0. Plus 2 plus negative 2 balances to 0. Here's the stable compound. So remember, a positive charge means that it is losing electrons to be like the nearest noble gas. A negative charge means it's gaining electrons to be like the noble gas. Let's try this one. Hydrogen, remember, is a +1. It looks weird, but just remember it's always a +1 because of where it's located. It's diatomic, so even if it loses an electron, it still has one left over in that diatomic compound. But in this case, bromine is a -1. Take a look at where it is. Bromine will gain 1 electron to be like its nearest noble gas, so a -1 charge. So then overall, one of each of them balances that charge and is stable. Sodium, take a look at where it is. Sodium is going to go from 11 back to 10 to be in the noble gas column, so it has to lose an electron. That's where that +1 charge comes from. But oxygen is a -2. Look at where it is. Oxygen gains 2 electrons to be stable. When it does that, it gets a -2 charge. It doesn't want to stay negative. These atoms want to come together to make a neutral, stable compound, so 2 sodiums adds up to a +2 charge. Oxygen 1 is a -2 charge, so together Na2O becomes that stable compound. So once again, that was the fast forward version of that lecture. If you still have questions, come to class with those questions and we'll clarify. All right, thanks so much for listening. Bye.